Lesson 11, represent proportional relationship. This is information that we already covered last year. So what you're going to do is, for the next 3 minutes, you are going to try to fill all the information from this page. So take your time, use the tools, your highlighter, your pencil, and in case you need to erase, make sure that you do it neatly. So you know how to identify proportional relationships and also linear functions. So let's look at this problem. Only the top runner in the world can finish a marathon in close to 2 hours. So we're going to highlight that. This graph shows the pace that one such runner followed in a race. What is the unit rate? And the unit rate comes from last year. If you see the information in the graph, the marathon pace, and then on the x-axis you have the time that it's increasing by 20s, and then on the y-axis you have the distance that it's increasing by 4s. As you can tell, the way that the graph is increasing by, it's constant. Now, this part tells you use math you already know to solve the following. So it says write the coordinates for point A and B. Remember, coordinates are going to be in the form in parentheses, and then you're going to put the x number and then the y number. So for point A, it's going to be, if you look right here, it's going to be 20 and 4. So you're going to write 20, 4. And for B, you're going to see that B is at 40 and 8. So you're going to write B at 40 and 8. Now it says, how do you interpret this point in terms of the number of miles run in a given number of minutes? So for this part, it's asking you for, so what this question is asking you is to put the information into context. So what does it mean, interpret, okay? So in this case, we know the runner runs 4 miles in 20 minutes. So let's write that down. The runner runs 4 miles in 20 minutes. That's what it means. Part C, how can you use the information above to find the rate per minute? So to do that, we are going to divide the number of miles by the number of minutes. Remember, rise over run. So divide the number of miles per minutes. Find the unit rate. So right now, let's just divide 4 divided by 20. Remember that we need to keep in mind the units in your answer. So we are going to get, if we simplify this fraction, 1/5. So 1 mile per 5 minutes. What does the unit rate means in the problem? So the unit rate means that the runner will be running 1/5 of a mile for 1 minute. Now let's find out a little bit more. It says, the unit rate can be represented by the slope of a graph. Okay, so the unit rate is the slope. So compare the point 0, 0 and 24. In the graph, on the previous page, it shows that the rise is 4 and the run is 20. The slope or rise over run is 4/20 or 1/5. Those two are equivalent fractions. You can also write 2 points on the graph to find the slope. Use the formula below with the point 0, 0 and the point 24. Label one of the coordinates x1 and y1 and the other one x2, y2. Then substitute the values for the variables in the formula for the slope. So again, this is our slope formula. Let's make sure that this is highlighted. It says that we have 4 minus 0, 20 minus 0, and we get 4/20, which is 1/5. The y-intercept on the graph on the previous page is 0. The graph of all proportional relationships include the point 0, 0, so that the intercept is always going to be 0. You have seen the equation of a linear function that follows the format y equals mx plus b, where m is the slope and b is the intercept. The graph of the proportional relationship also fits this format, but the value of b is always 0. And since it's always 0, then we don't have to write it down. So let's look at the equation for the graph on the previous page. So we know that the slope, we're going to write as y equals the slope m. So y equals mx plus b. Now we know that our slope is going to be 1/5 from the previous page. So m equals 1/5. And we know that b equals 0. So that's where they substituted. And now this is our equation. If you plus 0, it's fine, but it shouldn't be there. So this means that all proportional relationships are linear in which the y-intercept is 0. So let's make sure that you actually have all of this down, highlighted. Okay, now you have a couple minutes to fill the reflection part in a complete sentence.